Here's another problem involving a formula. V equals IR, a fairly common formula from physics. Given a couple of values here, both correct as three significant figures, we need to calculate the lower bound of I. And you'll notice that I is not the subject of the equation. So we need to rearrange the formula to get I the subject so that we can work out which bounds we need to calculate the lower bound of I. So if V equals IR, okay, therefore IR, just moving the equation from left to right to left, now divide both sides by R and we get that I is equal to V over R. And we've got a formula with a numerator on the top and a denominator on the bottom, which means calculate the lower bound. If we need this guy to be the lowest value, then the voltage has to be the lowest value, but the resistance has to be the highest value. So we need the upper bound of the resistance and the lower bound of the voltage to get the lower bound of the current. So first of all, the voltage, 208. And we know that's correct as three significant figures. So they've truncated 208 point something 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 to just 208. So what's the next one down from 208 in three significant figures? Well, it's going to be 207. And the next one up, 209. And the blue lines represent the barriers. You can think of this as a number line, really, a continuous number line, 207 point something, 0.1, 0.2, 0.3, 0.4, 0.5. So any value below the blue vertical line must be truncated to the value of 207. And any value above, up to 208. And the value at the barrier will be 207.5. Similarly, the value of the upper barrier here is 208.5. And this will be the upper bound, and this will be the lower bound. And from the work we've done already, we're going to need the lower bound of the voltage. Okay, now let's deal with the resistance. What's halfway between these two values? Well, it's 12.75, and this is 12.85. Now, from the work we've done earlier, again, we're going to need the upper bound of the resistance. So we're going to need this value. The lower bound of I, the current, will be given by the lower bound of the voltage divided by the upper bound of the resistance. And this, in our case, is equal to, pop that into a calculator and get 16.1478. If you quoted that answer, they might be mean enough to take a mark off. And the reason being, we've only got the voltage and the resistance quoted to three significant figures. So we can't expect the answer to be super accurate. This also should be three significant figures. And the cutoff point is here. Three significant figures, and we've got to lose the rest. Now, 478 is not quite up to 500 ... that we would need to push it up to 16.2. So our answer is that the current flowing through that circuit with the values that they've given, the lower bound of the current is equal to 16.1 amps. And that is your answer.